Sir, your voice got choked about in these 2 days.
Choke. Yeah. I think ऐसे ही हो गया बुखार हो गया Are you able to hear me like properly or what?
Yes, sir.
ठीक है I'll try to see how my voice holds up ठीक है okay so let us begin the class. I'll turn my video off. Okay. So today's topic of discussion is Pascal's law. Ta-da. Okay. So there was a scientist named Blaise Pascal. He was a French scientist, and he had given this law. Okay. So last class we studied about pressure, atmospheric pressure, different units of pressure, and we saw pressure due to a liquid column, which was rho gh. Right. So now, what does this Pascal's law state? Can anyone read this out? Who would like to read this out?
So me.
Okay, go ahead.
Pascal's law states that the pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions throughout the liquid.
Okay. So this is the Pascal's law. Now this is the definition, and let us see its application. So this is a demonstration of Pascal's law. In this there is a water bottle. Any water bottle में देखिए अभी क्या होगा आपका आवाज आ रहा है क्या नहीं आ रहा है हाँ अभी आ जाएगा So basically here we have a water bottle like this, and in the bottle there are some holes made. Okay. So as this person is putting water from the top, the water is coming out from the holes. Okay. So there is the top view of the same thing. Now observe carefully how the water moves and how far the water moves.
So equally the water moves out from all the holes.
Yeah. So as you can see here from all the sides, the water is moving equally. Okay. So ऐसे कुछ है. Like this is the water, so it is going to this side also. In all the sides, an equal distance is covered by the water. Okay. So what does this mean? This means that the pressure at all these points is same. Okay. That means pressure at all the holes is same. So now because the pressure at all the points is same, due to that the water comes out with same speed. and due to that the distance covered is same. Okay. So from this experiment, we can conclude that the pressure at all the points is same and the pressure is equally distributed, which is what the Pascal's law states. If you see it clearly again. Okay. So Pascal's law states that the pressure exerted anywhere in a confined liquid is transmitted equally. Okay. So सारे holes में same pressure हो जाएगा, due to which the liquid goes to same distance. Okay. Now there is one more example regarding this, जिसका application हम पढ़ेंगे अभी. Someone had asked कि confined liquid क्या होता है सर, है ना? किसी का डाउट था ना? What is confined liquid?
Yes, sir. I asked, sir.
Okay. So confined liquid means basically it is a liquid like this. Basically इसको हमने बंद करके जब रखेंगे, so it is a confined liquid. Confined का मतलब in one sense closed होता है, ठीक है. So अगर किसी liquid को close करके रखेंगे तो it is a confined liquid, ठीक है. Okay. One more example is syringe. Syringe पता है ना सबको? Syringe ऐसा होता है क्या? नहीं उल्टा बना था. So if you see a syringe also, syringe मतलब injection. Syringe. So the syringe also has a application of Pascal's law. So in syringe, what you do? You push the handle like this, and due to this, what happens? There is a pressure exerted in the tube, and due to this exerted pressure, whatever the liquid is there or water is there, it comes out from the hole. ठीक है. जो लोग डॉक्टर होंगे उनको शायद पता चलेगा. Okay, so this is the application of Pascal's law. So
Sir,
yeah, बोलिए.
sir, can you explain the last part of the law, that is undiminished in all directions throughout the liquid?
Okay. So suppose in this case only, what I do, I apply an external pressure like this. Okay. So I'm applying an additional pressure. This can be applied using a mass only. Suppose इसके ऊपर मैं एक डब्बा रख देता हूँ. So it is of 10 kgs, suppose. So now due to this, what happens? There is an additional gravitational force acting downwards, which is a 10g. Okay. Now due to this additional force, there will be an additional pressure, which will be force by area. This will be 10g by the area of piston, whatever the area is. Okay. So ऐसा there is the additional pressure added. Now due to this pressure, what happens? The Pascal's law states that this additional pressure is added at all the parts of the liquid. That means यहाँ पे pressure बढ़ेगा, यहाँ पे बढ़ेगा. So in all the parts of the liquid, the pressure is increased by an amount of 10g by A. ठीक है. This is the meaning of this. It passes undiminished. The 10g by A रहता है सब जगह पे, and in all the directions. So throughout the entire liquid. Okay.
Yes, sir. Thank you.
ठीक है. So does that mean that pressure at all the points is equal?
Yes, sir.
Yes, sir.
Yes, sir.
Sure. Okay,
So
sir.
the pressure increases with the increase in the, increase in the length of the water column.
Yeah, wait.
I did earlier.
Suppose I take 2 points. Suppose this is first point, the second point. So is pressure at first point equals to pressure at second point?
No, sir. No, sir.
Not free.
Sure.
Sir,
Yes, sir.
sure.
Yes, sir.
Sir, if the points are at same height, then only it is equal. If the points
Yes,
are
sir.
at different heights, then
Because the height of point 1 is and point 2 is different. The point
Mm.
2
Point
Okay.
2 will have more pressure.
ठीक है, ठीक
yes,
है.
the point 2 has more
समझ
pressure.
समझ गया समझ गया समझ गया. But इसमें तो दिया है ना कि pressure exerted anywhere in the liquid is transferred equally.
Say it is because they are in the same height.
No, no, no. So pressure equal नहीं होगा first of all. Pressure 2 will be greater than pressure 1. And this statement means that the increasing pressure will be same throughout the liquid. ठीक है. The increase in pressure will be same throughout the liquid. Okay. Throughout the liquid. Pressure will not be same, but the increase in pressure will be same. This is the Pascal's law. Is this clear to everyone? सबको समझ में आ गया?
Yes, sir.
Okay. Okay. So now this is basically many applications Pascal's law. हाँ बोलिए कुछ बोलो. So now this law has many applications. First is the application. ये आपने देखा होगा. This is called Stepney.
uh, sir,
Okay.
and in big garages, there is a hydraulic lift.
हाँ. So this is an application of Pascal's law. So what do we do basically in this? We apply a little bit force here. Okay. Color थोड़ा dark कर देते हैं. Basically what we do, we apply a little bit of force here. And with little bit force is able to lift a car. So if you try to lift a car by your own, hopefully कोई करेगा नहीं वैसे. So if you go near a car and try to lift it with your own hands, so you'll not be able to lift. Okay, because the car is very heavy, right? But same car can be lifted using this simple machine. Okay. So you apply a little bit force. Little नहीं होता है, so अभी ज़्यादा ही होता है. Still, you apply very less force. Compared to that, you get a lot of force here. Due to which the car goes up. Okay. So basically, we are applying a small force, but it is producing a large force. So the question is how? अगर आप कम force लगा रहे तो ज़्यादा force कैसे बन सकता है ना? So the answer is it is the use of hydraulic machine. So let me just explain this. little bit.
Sir, can I tell?
नहीं ये तो बताने दो हमको. So what is this? This is a machine like this. Okay. So very simple machine. In which we have water or some liquid filled up. Okay. So the liquid is completely filled up throughout the entire system. Okay. So as you can see here, the cross-sectional area of the piston is different. This area is little more, this area is little less. Okay. Let me call this is A1, this is A2. So my job is to lift this car, basically. So the system works like this. You apply a force on this piston. Let me name that as F1. Okay. So you apply a little bit force on this piston. So due to this, the piston will move downwards, right? थोड़ा सा नीचे आएगा. So let me call that distance as x1. Okay. Now, due to this, what will happen? This piston will also move a little bit upwards. Okay, let me call it x2. And due to this, there will be a force on this piston also. Okay. Just like if you take a water bottle full of water, I'll show here. If you take a water bottle like this, okay, this is a water bottle, and if you press this bottle very tight, I'm trying to press it. So what will happen? This ढक्कन क्या बोलेंगे इसको? Cap.
Bottle cap.
So this cap will experience a force, right? As soon as I press this bottle, this cap will experience a force. है ना? So I'm applying force somewhere else, but due to the presence of this liquid, the water, so what happens? The water transfers the force to the cap. समझ आ रहा है? So I'm applying a force here, but the cap will experience a force downwards. Is this clear? सबको समझ आ रहा है?
Yes, sir.
Oh, yes, sir.
Yes, sir.
Yes, sir.
Okay. So now, same thing is happening here also. You're applying a force on one part, due to which a resultant force is applied on the second part also. And this force is transmitted through the liquid, to the water. Yeah, बोले?
Sir, can you please explain that diagram again?
Which diagram?
Because I was there.
वही explain कर रहे थे. ठीक है. So the principle is because here the area is more and here the area is less. So
So the F2 will be greater than F.
the forces, ratio of the forces is in the proportion to area, A1 by A2.
A1 by A2.
ठीक है. So now here, because the area A2 is less than A1, that is why the force F2. एक गड़बड़ हो गई कुछ. एक मिनट. उल्टा होता है ना?
Yes, sir. It should be F2 by F1
या उल्टा होता है?
because here
Yeah,
if F1 is
F2
F1,
by F1. See.
it will be less than 1, and
So-
here in area it will be greater than
So
1.
the F2 will be greater than
Greater
F1.
than yes, sir.
ठीक है. तो जहाँ पे एरिया कम होता है वहाँ पे ज्यादा फोर्स आएगा. ठीक है. So basically what I am doing, I am applying a very less force here. Suppose I apply a force of 5 newtons. ठीक है. And this ratio is given as A1 by A2 equals to 100. That means I'll get F2 force is how much? 5 into 100.
500.
500 newtons. So the applied force is only 5 newtons. तो मुझे बहुत कम force लगाना पड़ रहा है. but the resultant force which I'm getting is very high, 500 newtons, 100 times 4. Okay. So same things happen here also in the hydraulic machine. So you apply very less.
Excuse me, sir.
हाँ बोलिए.
So can you minimize the screen?
Minimize the screen मतलब?
So actually in my side the screen is maximized, means it is zoomed. I don't know.
Sir, in mine also. Yeah, now it's okay.
Are you able to see क्या कर रहे हो?
Yes, sir.
Yes, sir.
Now also the screen is so big.
Screen is zoomed.
Yes, sir.
क्या समझ में नहीं आया. Now is it okay?
Sir, it's okay for me.
Okay for me also.
Yes.
Sir, maybe they have increased the size of the screen from their side.
ठीक है आप लोग try कर सकते हैं.
Yes, sir. Yes, sir.
Correct only, sir.
Okay. So what we do here, apply force F1 here, and the resultant force is F2. Okay. So now because the ratio of area is less, so accordingly the forces vary. Okay. So this is called a hydraulic machine. You give a less force as input, but you get a very high force as output. Okay. अच्छा है ना? कम काम में ज़्यादा काम हो रहा है. So this is used as like काफी जगह use करते हैं इसको.
Sir, can you just explain it again?
क्या एक्सप्लेन करना है? Which part you want to explain?
F1 equals to 5 Newton. Did you give the example?
Yeah, example only. हाँ example था ये.
Yes, so then it's okay.
Okay. So now this hydraulic machine has many uses. It hydraulic press में use होता है. ठीक है. Cotton का sheets बनाने के लिए use होता है ना. And hydraulic lift में use होता है. So basically जो यहाँ पे कार को उठा रहे इसको hydraulic lift बोलते हैं. So again this is used for lifting cars.
Yes, sir. And also very big and heavy vehicles, sir, like truck.
Yeah. So these are some of the uses of Pascal's law. Okay. So basically in all these different cases, there's an advantage. The advantage is present because we are applying less load, we are applying less effort, but
More
you're getting
yes,
more.
less effort.
So this ratio of load by effort is called mechanical advantage. Okay. And this advantage is greater than 1. Means effort आपका 5 newtons था, but आपका load output 500 newtons है. So this is called mechanical advantage. And
So, but I didn't understand why you have written it is greater than 1.
because the ratio of area is adjusted in such a way, we got F1 by F2 equals to A2 by 1. So if A2 by 1 is greater than 1,
Sir, we studied about mechanical advantage in class 6.
ठीक है. So A2 by 1 अगर 1 से ज़्यादा है, that means our F2 will be greater than F1. है ना? सही किया ना? And F1 will be greater than F2. So generally we use such machines so that we have some advantage. ऐसे कोई compulsory rule नहीं है that advantage should be greater than 1. It can be less than 1 also. But we want the advantage. That is why we design the machine in such a way so that the advantage is greater than 1. We want more load and with less effort. Okay. So we design it in such a way that this ratio is greater than 1. Okay, Anushita? अगर कोई compulsory rule नहीं है.
Okay, sir.
ठीक है. Similarly, this velocity ratio, this distance moved by the effort divided by distance moved by the load. ये भी generally greater than 1 होता है.
Sir, if it is less than 1, then it will become a third class lever.
ऐसा. Okay. So ये हमारा Pascal's law हो गया. Let us do some problems. कुछ problems करते हैं. This is a very interesting problem which I found out. Okay. So this is the first problem. So here we have water filled like this, and different points are given. This point A, point B, point C. So this distance is given as 60 centimeters. This distance is given as 40 centimeters. And the length of the tube is given as 20 centimeters. So basically you have to calculate pressure at point A, pressure at point B, pressure at point C. Okay. This is the first part, and second part is what is pressure at point C if tube is made vertical. ठीक है, try करो इसका. You can take the value of atmospheric pressure as 1.013 into 10 raised to 5 Newton per meter
So
square.
we need to find the total pressure.
Yeah.
Okay, sir.
किसी का आंसर आ गया क्या? Okay. Anyone with the answer? किसी का आंसर है क्या? You can raise your hands. Okay. किसी का आंसर आएगा क्या? इससे पहले क्वेश्चन ज़्यादा टफ हो गया.
I'm not able to see the second question completely. Yes, now it is.
किसी का आंसर है? Anyone got the answer? Yes, Ashmita. Adi. Yeah, what tough है क्या question? Okay. Okay, then let me begin with a simple one. We'll do this थोड़ा बाद में. थोड़ा easy question करते हैं पहले. Question 0. Suppose I have a container of water like this. ठीक है. And there are 3 points. This is point C, point B, point A. This distance is 10 centimeters. This is 30 centimeters. So now what is the pressure at point B? Point A, B and C. Simple. यार कैलकुलेट कर सकते हैं. ये तो एकदम सिंपल है. ठीक है. प्रेशर एट ए, बी एंड सी. Density.
So total pressure.
Total pressure. Density of water is 10 raised to 3 kg per meter cube. 1000 grams.
Sir, and point A is exactly at the starting of the container.
Yeah.
Okay, sir.
बताइए. Surprising.
Sir, we'll consider point A's height to be 0 or 1.
Great होगा ना. First time I'm seeing silence in class 9. बाप रे. Pretty easy है, but tough नहीं है. तो डरो मत. Very easy. At least ये question तो बहुत easy है. Would anyone like to answer this? Yes.
Yes, sir.
Calculation is very big. Okay. ठीक है. So let me just solve this. Pressure at point A. So our point A, this is just at the surface. So because this is just at the surface, so it is in contact with the atmosphere. Okay. So pressure at point A will be atmospheric pressure.
Sir, sir, 1.3
013.
This is 0.
into 10 to the power 5.
Pascal.
Yes, sir.
Okay. This is pressure at point A. Now pressure at point B.
Point B is
अधिक बोलने दो बोलने दो बोलने दो
1.0.
बोलने दो
Okay, sir.
ठीक है आपका आगे आंसर पता है हमको so pressure point B will be now this is a liquid column इसमें थोड़ा पानी है and the point B is below this liquid column ठीक है so pressure at point B will be pressure at point A plus pressure due to the liquid column between A and B this liquid column so this is how much this is rho G into H okay so this will be 1.013 into 10 raised to 5 into rho is plus rho is 1000 into
Sir,
9.8 into
9.8 into 0.6.
sir, we have to consider 9.8 and
Oh, sorry, the 0.1. Sorry,
G
sorry.
as 9.8.
हाँ so this is
Yes.
Sir, I was considering 10.
this will be 1.013 into 10 raised to 5 plus
So we are considering the height as a 0.1 because here it's 10 centimeter.
yeah
right?
yeah
Yes, sir.
so हो जाएगा
So it will be 98.
980
980, sir. 980.
okay तो कितना है 980 को आप लिख सकते हैं this is 0.98 into 10 raised to
Sir, otherwise we can convert it in a normal
one-
form and then add and then change it to the
नहीं ठीक है
scientific
ठीक है
form.
Sir,
better
1.022 into 10 to the power 5.
80
Yes. Into 10 to the power.
okay so this is pressure at point B okay
Sir, B, I guess.
हाँ B only
Sir, that will be if. So correct. I only thought.
So can you scroll the page?
then pressure at point C this will be pressure at point A plus pressure due to the entire liquid column so this will be rho GH rho G into H dash जो अलग H है so this will be 1.013 into 10 raised to 5
Into 5
plus
plus
1000 into
1000
9.8
into 9.8 into 0.4.
into 0.4 okay ऐसे होगा
Yes, sir.
Why are we considering pressure at point A? Why not point B?
हाँ B भी कर सकते हैं but then you have to change the height then उसमें height 0.3 देना पड़ेगा
Okay, sir.
okay
Yes, sir.
Sir, I was considering G as 10.
better
It
to
should be,
consider
sir, it should be
8
9.8.
should be
better to consider 9.8 because if it is not mentioned you should take it 9.8 okay
So can you scroll the page downward?
yeah why not? कुछ है ही नहीं नीचे क्या ऐसे so is this clear to everyone कोई doubt है इसमें किसी को
No, sir.
जिसको डाउट है वो पूछ सकते हैं ना is this clear to everyone Hadi Srijita
Sir,
Yes, sir.
sir, what Ashmita said, sir, if we do like that, if we add point B, if we consider point B, then we need to take the height of the liquid column as 30 centimeter.
yeah yes correct अरे पहले बोलो भाई समझ में आ गया सबको is this clear
Yes, sir. Yes, sir.
अद्रिका
Yes, sir.
समझ में आ गया तो
Yes, sir.
Sir, can you show the solution to the previous question?
हाँ करेंगे ना पहले ये तो समझ में आना चाहिए
Yes, sir.
this is first 0th question okay सब लोग शांत है इसलिए हमको भी अजीब लग रहा है ठीक है ना लाइफ में okay
Yes, sir.
so yeah so in this question again we have to find out pressure at A B and C okay so if you carefully observe this is our point A. So here the pressure, this point A is in contact with the atmosphere outside here. So the pressure will be PATM or atmospheric pressure. So again we know the value of atmospheric pressure, तो उसको लिखने की जरूरत नहीं. Now pressure at point B. This will be pressure at point A plus pressure due to this liquid column.
Liquid column, yes, sir.
Okay. So this will be PATM plus rho GH. Okay. So now the confusion comes.
Sir, what is the density, sir?
So now the confusion comes that ये H के लेंगे because the liquid
Yes, sir.
column is
So it is
not
tilted.
tilted, right? So H के लेंगे.
0.6.
बताइए. What is the value of H? So this when we derived this also, I think जो हमारा pressure due to liquid column आता है, it is rho GH, and H is always the vertical height between the 2 points. So जो vertical height है हमको उसको consider करना होगा.
0.6.
ठीक है. ऐसे. So this will be ATM, PATM plus rho GH. So you can calculate this. Plus
5 plus
rho G into
9.6.
if you calculate this, तो आपका आंसर आएगा. So this is the pressure at point B. Okay. Similarly, pressure at point C. This will be PATM plus rho GH. But इसमें H change जाएगा. This will be 1 meter. 60 centimeter plus 40 centimeters. Better to write it elaborately. 60 plus 40 centimeters. 0.6, 0.4. Okay. So again, if you solve this, आपका आंसर आ जाएगा. So this is how we find out the pressure at different points. Basically, इसमें वो Pascal's लगा application नहीं है. This is जो last class में पढ़ा था उसी का application. Pressure due to liquid column. Okay. Now the question is, what will the pressure at point C if the tube is made vertical? So
Sir,
as soon as
it
you
is
make
coming 1.111.
as soon as you make the tube vertical, so what happens?
Sir,
So the entire liquid it becomes vertical. So this is point A, point B, point C. So we can write here pressure at point C and second pressure at point A plus
press
this height. So this height will be 200 centimeters.
that is 2 meter.
So this is rho G into
GH 2 meter, yes, sir.
and this is the atmospheric pressure. Okay. So again, if you calculate, आपका आंसर हो जाएगा.
Yes,
So,
sir.
so this is how you do it. Okay. So को समझ में आ रहा है तो?
Yes, sir.
Is this clear? Swapnabit, Rajiv? Yeah.
Yes, sir.
Yes, sir.
बाकी लोगों को अद्रिता, श्रीजिता?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
ठीक है. So एक टाइप क्वेश्चन हो गया. Now एक और क्वेश्चन कर लेते हैं जल्दी से.
Just go on.
So suppose we have a liquid like this, liquid column. Okay. And in which a mass is kept. Mass m. ठीक है. So different distances are given. Let this distance be h1, the top of the surface, and the bottom surface has a distance h2. Okay. And the density of water is given as rho w. The density of solid is also given as rho s. Okay. So these things are given, and the cross section area is also given. So this is the cross sectional area. So now the question is some different question there. What is the pressure at top surface? Then you have to find out the pressure at bottom surface. Okay. So now you have to find out the pressure difference also. Pressure difference between the two surfaces.
Sir, values of H1 and H2 are given.
No, they are H1 and H2 only.
Sir,
And
what is the second row for?
density of solid.
Okay, sir.
Cube का density. So pressure difference you have to find out, and accordingly you have to find out the thrust force acting on the cube. Okay. So इसको try कर सकते हैं.
The thrust force on the cube.
Thrust.
Yes, on the cube. Okay. I am not able to see the. Yes.
Try कीजिए इसको.
Sir, we need to find it in terms of pressure of the atmosphere plus something.
Yeah. Variables के terms में रहेगा.
Okay, sir.
So, pressure at the top surface, is the pressure of top surface of water or the solid?
No, solid. Yeah. Any other. This is the top surface, this is the bottom surface. Okay, Anushita.
Okay, sir.
Can we represent density of water liquid as
As what?
OL?
Rho. हाँ, rho W ले सकते हैं ना. Density of water.
Oh, it is water.
हाँ.
Any other liquid. So it will be 1000 किलोग्राम पर मीटर।
नो टेक इट एज वेरिएबल ओनली ना, रो डब्ल्यू के टर्म्स में आंसर नहीं करना. एवरीथिंग इज वेरिएबल हियर ना, सो सब वेरिएबल के टर्म्स में नहीं करना.
Sir, G will be also taken as variable.
Obviously.
Yes, sir.
Sir, I took it as a numeric value.
अरे सब वेरिएबल में रखो ना, सिंपल, डोंट सब्स्टिट्यूट एनीथिंग.
Okay.
Okay, sir. Sir, I got it.
Yes, sir. I too got.
See, can you tell the question number D? I cannot see it.
ओके, सबका आ गया आंसर.
Done.
Okay. So let us try to solve this. So I'll solve this. You can just check if your answer is correct. Now pressure at a top surface. So this pressure, this will be pressure of atmosphere.
PATM plus
This will be atmospheric pressure plus rho g into
rho
H.
W.
Yeah.
Sir, rho W.
Rho S.
हाँ अभी तो आया. अच्छा, तो ये रो क्या होगा, ये पहली बात है. रो जी इंटू एच हो गया, ये पता है हमको.
HO1.
So according to Archimedes principle which is studied, Archimedes principle पता था क्या मैंने?
Sir,
No, sir, but we
next
studied
chapter.
it in class 8, sir.
Class 8, sir.
ओह, मैंने Archimedes principle नहीं बताया था क्या?
नहीं सर, अभी तक इसके बाद हम लोग के बुक में
बाद वाला
आर्किमिडीज चैप्टर है सर.
ठीक है, वैसे यहाँ पे एप्लीकेशन ही है उसके जैसा क्वेश्चन. ओके, सो या The extra pressure which is added due to liquid column, this is rho g into h, है ना? जहाँ पे rho हमारा होता है, this is the density of surrounding liquid. Density of surrounding liquid. Okay.
Sir, we are having chemistry class from 6.
हाँ, मैं सर को बोल दिया सर, बोले ठीक है.
So we'll take it as row of water.
Yeah. So rho water into g into h. Okay. Because जो pressure आ रहा है, that is due to water, right? It's not due to solid.
Water. Second one will
Oh
be
yes, okay.
ऊपर में जो
Cold.
water है,
Okay, sir.
Yes, sir.
उसकी वजह से pressure आ रहा है.
second one will be solid.
ठीक है. So this is the pressure at the top surface. Now, यार समझ में आ गया सबको? Is this clear? Srita,
sir.
Anushita,
Yes,
Arshita.
Yes, sir.
Hadi, is this clear?
Yes, sir.
Okay. So P will be PATM plus rho W into G into H. Now pressure at bottom. ठीक है. अभी कोई कुछ बोलना मत क्योंकि बहुत लोग आंसर गलत होगा इसमें. So कोई आंसर बोलिए मत, ठीक है. I'll tell the answer. And you check आपका सही है कि नहीं.
sir, can I try?
No. No trying here. क्योंकि मुझे पता है आंसर गलत होगा बहुत लोगों का. सही भी हो सकता है. This will be PATM plus, ठीक है, H2 तो रहेगा, G भी रहेगा.
Rho S.
नहीं, यहाँ पे भी रो W रहेगा. Okay.
Why, sir?
So again, this is liquid pressure due to liquid column. ये आजू-बाजू में liquid column है ना. तो उसके से pressure आएगा. Okay.
Okay.
So you get pressure at bottom will be PATM plus rho W into G into H. So this is this B part. Now C part is pressure difference between the two surfaces. So this will be P bottom minus P top. So this will be
equal to
rho W G
rho W
minus H1.
H2 minus H1.
H2 minus H2.
minus H1.
Okay. So now thrust force will be basically due to this pressure difference, there will be a thrust force. So this force due to thrust. This will be pressure difference P bottom minus P top multiplied by the area.
Into area.
So this will be rho W G A into H2 minus H.
H2 minus H1.
Okay.
So this sum was easier than the previous.
Yes, sir, it was easier.
Yes, sir.
Okay, easier than what?
The previous sum.
Previous sum, sir.
Yeah. So actually this thrust force, this is due to the pressure difference created by the liquid. And this thrust force will be acting upwards. Okay.
So what is that A for?
A is the cross section area.
Okay, sir.
Okay. ठीक है. So actually यही thrust force को हम लोग buoyant force बोलते हैं. buoyant force सुना है ना आपने?
Yes, sir, buoyant force.
Yes, sir.
So this is the buoyant force actually. Okay.
Yes, sir. Acting downwards.
ये buoyant force ऊपर act करेगा तो.
Yeah, so
The weight
weight
will act
will act downwards.
Yeah, weight will act downwards, but this buoyant force will act
Buoyant
upwards.
force will act upwards.
The upward force.
Yes, sir.
So there will be thrust force like this, and downwards there will be mg gravitational force. Okay. तो नेक्स्ट टॉपिक मैंने पढ़ा दिया आपको आर्किमिडीज प्रिंसिपल. ओके. ये वाला सबको समझ में आ गया? कोई डाउट इसमें?
No, sir.
It is clear to everyone.
Sir, can you scroll upwards? I have a doubt.
Where?
Sir, can you go to the second sum which you gave? Second one. Yes, sir. Sir, there in PB, there you multiply in place of rho GH, you multiply 1000, that is value of rho, then 9.8, then H you have written in meters. In which unit?
It's the 0.1 होगा ना? 0.1. Meters.
Oh, is it 0.1?
Yeah.
Oh, then it's okay.
पहले कैलकुलेटिंग मैंने कैंसिल किया है एक पॉइंट का और कुछ. ओके. और बताइए और कोई डाउट है आप लोगों को? It is clear? अरे कोई कुछ बोल नहीं रहा. अद्रिका it is clear? आदि.
Yes, sir.
Yes, sir.
ये आपको क्लियर है? क्या हो क्या गया आप लोगों का?
Sir, it's clear only.
Yes, sir. It's
Yes,
clear.
sir, it is clear.
Yes, sir.
Yes, sir. It's clear, sir.
क्लियर है सर? सब लोग एक बार वीडियो ऑन करो. तो मतलब गए हुए हैं क्या? ओके. क्लियर है तो? हाँ. देख के तो नहीं लग रहा है. देखो पवन का तो चेहरा ही गायब हो गया. देखो
Sir,
कुछ क्लियर
clear है sir.
क्लियर है.
Yes, sir.
हाँ.
Yes, sir.
अद्रिता इज क्लियर?
Yes, sir.
तो इसमें कुछ बोल क्यों नहीं रहा था? सब लोग शांत है. टेंशन.
Sir, we told that we understood.
सर ठीक है. तो ये था हमारा क्लास आज का. क्लास खत्म हो गया. तो आपको होमवर्क देना भूल गए थे हम लास्ट वीक. तो एक्चुअली हादी हैज ऑलरेडी डन
Sir,
है.
are the class
क्या?
are the classes becoming shorter?
नहीं आज शॉर्ट हो गया. 4:45 से हो गया मोस्टली. तो आपको होमवर्क क्या था? द होमवर्क इज लास्ट वीक आई वाज ट्राइंग टू टेल you have to take a pipe and demonstrate how by changing the area of the pipe you can change the speed of the water. ठीक है. So इसको demonstrate करना था. You have to show कि when the pipe is pipe को जो दबाते हैं.
Sir, you told that you will give that equation of continuity. If we measure the distance
yeah.
of that water. Sir, I did not do.
So ये distance speed पे depend करता है. Okay. So you can find out this distance if you know the speed. And speed depend करता है area पे. ठीक है. So आपको experiment में क्या करना होगा? You have to basically fix the length of the pipe, height of the pipe, and tap on करना पड़ेगा. And for 2-3 cases you have to change the area. ठीक है. So as soon as you change the area, आपको ये distance change हो जाएगा. Water ज़्यादा दूर travel करेगा या पास में travel करेगा. ठीक है. So depending on that you can find out the speed भी. ठीक है. So you have to find out different speeds at which the water is coming out. So ये आपका experiment है.
So we have to find out a different speed,
Different speeds at which the water is coming out.
not the distance.
Distance कैलकुलेट करने से तो स्पीड निकलेगा.
Yes, sir.
ठीक है. So basically ये height आपको known होगा because you will be fixing the height. आप छोटा सा height रख सकते हैं. कार्डबोर्ड रख सकते हैं या फिर कंपास बॉक्स समथिंग. टेबल के ऊपर रख सकते हैं. ठीक है. So this is the experiment. And you can demonstrate Pascal's law also. That can be an alternate experiment. But जो मैंने दिखाया वो नहीं करना है. पानी में बॉटल में छेद करके. You can do some other experiment to demonstrate Pascal's law.
Yes, sir.
ठीक है. Okay. And जिन्होंने पहले कर लिया उनको फिर से करने की जरूरत है. So Hadi has already done the experiment. You can just submit that.
Sir, you will send that about that experiment in the Google Classroom, or we'll directly do?
Yeah, I'll send. Don't worry.
Okay, sir. Yes, sir.
Okay.
Okay, sir.
ठीक है. So I think you can end the class here. अच्छा उसका उस दिन वो हुआ था ना कुछ तो भी. क्या हुआ था? We had a mini celebration. आप लोग थे उसमें?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Oh, how was it?
Nice.
Sir, it
Sir,
was
very nice.
Was it inspiring or?
motivational.
Motivation.
So it was
Okay, nice. So this is the beginning actually. सिर्फ बोर्ड का रिजल्ट है तो. Now they will be giving mains. अब उसके बाद एडवांस भी देंगे. ठीक है. उससे थोड़ा ज़्यादा मोटिवेशन होगा आपका. ओके. ठीक है. So क्या करेंगे अभी? क्लास खत्म कर सकते हैं. अगर केमिस्ट्री क्लास है अभी. Okay.
Yes, sir.
Okay. So thank you very much. Thank you all.
Thank you, sir.
Thank you,
Yes, sir.
चलो.
Thank you, sir.
Sir.
Thank you very much.